Welcome to page 4. Let's get started. Write the standard form of the equation of the function that has the indicated vertex and whose graph passes through the given point. And that is really like what we were just talking about on 37 and doing on 38. And I actually did those two different ways, the way the book might intend for you to do it and the way I might do it myself. And you can take your pick. I'm going to show you both of those methods for number 40. Standard form of a parabola, y equals a times x minus h squared plus k. Here are the puzzle pieces we need. We need those three pieces. I need a, I need h, I need k. Love it when they give me the vertex. That's hk. So far I've got y equals a, I don't know, x minus 4 squared plus 1. And then they give us a point. And a point on the graph, this is an x-coordinate and a y-coordinate that satisfies that, which means I can replace y with -7. A, I don't know. Replace x with 6. Plus 1, solve for a. Subtract 1. 6 minus 4, 2 squared. That's 4 times a. So a equals, divide 4, -2 in our equation is y equals -2 times x minus 4 squared plus 1. And that's it. And you might prefer that. I have no problem with that whatsoever. Like I said, many before you have done it that way. Here's what I would do to get the a value. Once I've got this, from the vertex to the point, we go to the right 2 to get from 4 to 6. And to get from 1 to -7, we go down 8. Now normally, regular old parabola goes right 2 up 4. Not this one. It goes right, bad 2, down 8. That's twice as far and upside down. A is -2. Twice as far, upside down. So I'm going to approach it that way. You do not have to do that. You can go ahead and use this substitution method that we used right there. Okay, so I've got this graph goes from -4 to -2. That's to the right. Draw a line. To the right 2, and then it goes from -4 up to 5. It goes up 5. Regular old parabola goes to the right 2, up 4. But this one goes up farther than that. And how much farther? Well, it's a fraction farther. What was 4 became 5, so the fraction's either 4/5 or 5/4, but it's bigger than normal. So a is 5/4. You might choose not to do that. Perfectly understandable, but you're going to see me do it enough times that you might get comfortable with it. Therefore, our equation is y equals 5/4 times x minus 4, x minus -4, so x plus 4 squared minus 1. And all of that just by analyzing the standard growth. Normally over 2, here's up 5, normally would only get me up 4. So it's bigger than that. My fraction was either 4/5 or 5/4, but since we're growing taller, I choose the taller 5/4. Okay, so let's take a look here. From -1/4 to 1/4, I'm going over 1/4 from -1 to -17/16, or from -16/16 down to -17/16, we're going down 1/16. Oh my goodness, fractions, this is going to be tough. Well, what would over 1/4 usually get us? Over 1/4 would just get us up 1/16, because it's y equals x squared for normal. 1/4 squared up 1/16. This is down 1/16. It's just upside down. A is -1. So y equals -1 times x plus 1/4 squared minus 1. I've got all three puzzle pieces. And I don't know about you, I always kind of get a kick out of trying to shortcut the system. But again, you can use this as the model. If that's just out of your grasp a little bit, no problem with that whatsoever. Okay, a little trouble with the directions on 45, 48. Determine the x-intercepts of the graph visually. Well, it appears as though an x-intercept is -1, -2, -3. It looks like -3 is, and this one, I don't know, maybe that's a half, maybe it's 3/5, maybe it's 2/3. I don't know for sure over there. It says, then determine the x-intercepts of the graph visually, then find the x-intercepts algebraically. So x-intercepts algebraically, that means the x-intercepts occur when the height is 0. When the height is 0, y is 0. So I want to have 2x squared plus 5x minus 3 equals 0. And here I would not I would not write this, in standard form. I would quadratic formula this. So x equals the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a all over 4. So there we have quadratic formula. The most common mistake people make is they don't deal with the negatives properly in this. Make sure to put the -3. So this is -5 plus or minus square root of 25. A negative ultimately times a negative is a positive. That's 2 times 4, 8. Times 3, 24. On 4, so I get -5 plus or minus square root of 49. How convenient. On 4, I get -5 plus or minus 7. On 4, that is -5 plus 7, 2/4. -5 minus 7, -12/4. And we do have, therefore, x equals 1/2 -3. It is kind of nice to look up there. Oh yeah, I guess that could be 1/2, and that does look like it's -3. Okay, now x squared minus 6x plus 9. I can go to quadratic formula, but I also notice this thing is factorable. This is x minus 3 times x minus 3, or x just equals 3. You could make an argument it's 3 and it's 3. But the x-intercept occurs when x equals 3. That is actually called a double zero, and that's going to be a conversation we're going to have later on in this chapter. So if you can factor it, great. Maybe I could have factored this one. Negative factors, I don't think so, but factors of -6 that add up to 5, 6 and -1. Oh, could have. Of course we could, because this didn't turn into a square root. This was factorable as well. Quadratic formula worked there. Perhaps you can get by with factoring both of these. But if you can't factor, quadratic formula is always there and available for you. Let me know what I can help with. Should be a fairly quick page.